Hi, my name is Tim Deneen, the die guy with Food Extrusion Dies, and this is Die Talks. This will be our third video, and this one's going to be on die steels, specifically, grab our chart, who, what, and why of die steels. You know, why do we use this steel there? Why do you use whatever? Lots of manufacturers of dies just make dies out of what they make their die out of. That's it. And it's usually, you know, a D2 or a 300 series stainless. And that company particular makes all their dies out of that. We're different that way because of our continuous improvement. We look at what our customers having issues with and we decide where to go. Unfortunately, there is no like perfect die steel that solves all the situations for everything. The two main characteristics that we have is, you know, die face wear. So when I mean by die face wear, I mean, grab a knife real quick, is the face of your die and the knife running across it. That type of wearing. The other type of wearing we have is through the inside of the die. And through the inside of the die, meaning this or your finger, even if there's not a finger on there, but basically through your inside or the feed part of your die. So there's two different things that do that. The die face wear, is what we were talking about, is on this side of the scale. And then the inside wear, which is also corrosion wear, that's on the other side. So when our customers come to us and we're evaluating where they're at to keep up on the continuous improvement, we see where they're at and where they want to be. And that's where we adjust die steels for our customers. Along with die steels, we're also going to talk about PEEK, which is a high temperature, high pressure plastic that we have currently been using to make dies out of for many, many years right now. I think we've been using this for about 15 years. And lots of companies use this because it has a low coefficient of friction. So getting back to our scale we have on here, we have a high coefficient of friction, which is a better die face wear. We have the low coefficient of friction that doesn't wear as much on the inside of the die. Now, along with the coefficient of friction and wearing on the inside of the die, we have certain scenarios where you need a low coefficient of friction. And what that is usually has to do, most of our companies, they're pet food companies that do it, but what it pertains to is a long part. If you're extruding something that's more than a half an inch, or, you know, right around a half an inch or a couple inches long, it will get a rough texture on the outside or an interrupted edge. I thought I had one. When I say interrupted, what I mean is the roughness on the side of this. So in that case, when we want to remove that, we go more towards this area right here. And, you know, we may start with the 300 series stainless. We also have RT3. And again, if you notice, on all these bottoms, we have, this is the generic types of steel. You know, D2, 400 series, 17.4, 300. And then Food Extrusion Dies proprietary stuff, which we source out the highest. And a lot of times it may not be exactly 300, but it is something better than that. Where we have our T9, which is our most popular die steel because of the face wear. That is nothing like D2. It's a powder metal substrate, and some of these also are. But there are proprietary steels and heat treating. So if you see those numbers on here, that's what we'll be talking about later. Getting back to coefficient of friction. The end of these, where we have, you know, 300 stainless steel, that's at a pretty low coefficient of friction, very smooth. Plus we can polish the inside of it. Then you get down here to PEEK, which has the best coefficient of friction. So if you're trying to get something really smooth to come out of there in the long areas, that's what you're going to end up being to. And we could take those inserts, we can make just about nearly anything out of them, and then we could put these in a hardened die face that actually is our T9 insert holder, and the knives will help, writing on that will help the wear of it because it won't be wearing on a whole, you know, die face or something like that. So that's PEEK. So next steel we're going to go over is T3 or 300 series stainless. Again, I went over the differences of our T3 as a higher quality, but so let's go over 300 series stainless. Mainly what those are made out of is going to be We can make inserts out of there, and sometimes the situation requires it, but we always make, the cones on the back of the dies, if it's not built into the die, transition pieces in the back, anything that doesn't get a knife gut on it that is not a pin, we make out of 300 series because it's the lowest coefficient of friction, it wears the least, and there's literally no damage or beating or anything happening to it. The other thing with coefficient of friction is it doesn't allow things to stick to it as much. So as you're having things come down your process, it doesn't stick to it. Things that stick to things end up staying there, overcooking, burning, and having bad effects like specks and chunks and streaks and stuff. So anything behind the die we usually make out of the 300 series stainless. Okay, so the next die type we're going to talk about, die steel type, is 17-4 pre-hard. So that is a material that you don't heat treat. It comes at a certain hardness, which makes it a lot more rigid than a 300 series. Again, 300 series you cannot heat treat. It is unheat treatable. It is what it is. It's pretty malleable and soft. So when we're making pins, we want to make it out of something that doesn't rust and corrode. And 400 series stainless, even though it says stainless, it does corrode and rust. It is not nearly as rust as 300. So 17-4 is someplace in the middle. And we use that to mainly make a lot of our pins out of. As you can see, certain types of these dies, I'm going to grab them up real quick, that have intricate types of pins on them. If I get those in the camera, you kind of see some of those. They have a lot of different shapes cut into there. It's not very easy cutting small shapes like that. Anyways, with those type of pins and even a regular straight pin that goes in a die and things like this, we make all those out of 17-4. Just because the biggest problem customers have with pins, not only the corrosion, is it just bending for no reason at all. That's because it's usually made out of a 300. 17-4 allows it to be more rigid in there, and it's not as easy to bend, and it goes back to its center thing more. And basically, that's the reasons why we use 17-4. We don't use 17-4 on the die face. We don't use it on the cones. We don't use it on transition plates. We just use it on the pins to help a little bit more rigidity and to make it easier to machine certain things inside of there, So that is 17-4. Okay, next on our list is 400 series stainless. So 400 series stainless is a heat treated or hardenable stainless. It has more carbon in it than the 300 series, and that's what makes it able to be heat treated and hardened. It has a better or a lower coefficient of friction than D2 and T9. It's closer to this way, but it still has a higher friction than 17-4. Where do we use 416 at? Well, 416, if we have customers who they're wearing from the inside, corroding like little fingers on the inside of there, or just a hole expanding faster, we will go from a D2 or a T9 and we'll back it up if they're not having knife wear issues. Again, there's no best thing for everything. There's each customer and what that product's sweet spot is. So if they're not experiencing knife wear, but they're experiencing wear on the inside of the die and corrosion, we may back them off of that and put them to a 400 series stainless. Again, every customer and every product has its sweet spot. And that basically is 400 series stainless. So next on our list is D2. And that's also, I think the European numbers for that is 5200, but it's most commonly known as D2. Years and years and years ago, it actually used to be known as the semi-stainless. In other words, something that was in between a tool steel and in between a stainless. It was actually noted and called that in many terminologies. But D2 is a heat treatable steel. It's very good on knife wear on the face. It does have some corrosive properties, but if your die is taken care of and cleaned well, it should be okay. It's not what we use most of the time. We're going to get into that in the very next one, which is T9. But that is basically D2. Again, if that's where most die people make their dies out of, That's the most commonly used in food extrusion dies is D2, that other than a stainless. And that is basically D2. Okay, so the next die steel we're going to talk about is our proprietary T9. Now that is a highly engineered powder metal substrate steel that what that really means that when it's manufactured, it's ground into particles that are 10 times smaller than your standard steels like D2, which makes it a lot tougher and makes it wear a lot better. It also allows us not to make it as hard on your Rockwell C scale. Instead of it being 68 or 62, it's actually in the low 50s. This allows it to be tougher, not to crack or break, and because it's that powdered metal substrate that's a highly engineered steel, it lasts 6 times longer, roughly. We've seen it 10 times, 3 times. It depends. You know this. It all depends on how people handle things. But it lasts approximately 6 times longer than D2. Similar to D2, you have to take care of it. It has to be washed and dried off because it will corrode if it's not taken care of. But as far as our most popular steel, it is the T9 steel. That is by far our most popular. Not that it's the best in any way, it just satisfies most of our customers' needs. We do have customers that strictly use PEEK dies or PEEK inserts and other things, but our most popular is the T9, which is our proprietary steel. We also have a proprietary heat treating process that we've been developing for about 17 years now. That's why it lasts 6 times longer. So again, my name is Tim Deneen, the die guy with Food Extrusion Dies. This is Die Talks signing off, and we will see you guys later.